his best day was moving 600 sheets inside the windstorm in 2 hours. So rearranging, he moved 600 sheets in a couple hours.
So a couple of hours?
Yeah.
It sounds unfathomable. He was just changing the configuration of the windstorm.
He wasn't making strokes a full night or heating the machine.
His windstorm,
He's the only one.
like this windstorm,
Yeah, he's the only one. That's the crazy one.
he's a little guy out of left field. This machine has brushless motors on the x-axis instead of traditional wound motors, so it can move at 150 meters a minute in the x-axis. So that's how you achieve it.
Yeah.
It's
The
fast.
bar fit, I had we had a bar fit.
Oh, yeah.
Tracking system and this one.
Yeah, but you're only moving short distance. Okay, so moving on to, before we open it.
Real quick, I just want to reiterate what Jim said. Jim, you believe that if you were to do this, you could replace the 2 panel cells you have and the 3 routers.
He's going back to that
I'm
paycheck.
going back to paycheck.
Yeah.
He's betting his paycheck. I just want to
You got
confirm.
that wrote down, though.
I do. I have that written down in my book. So you believe you can do it?
I believe that, yes, I do. I really do.
Really?
You know, underline that.
There's one thing, in the Seattle layout, you saw a panel cell similar to this one. I think in Seattle, they could just use a front load machine, not with the external conveyor. Here, I think that's the right solution. Why? Because you can do your one-ups from the wind store, and you can put your full bundles of 3/4 inch white melamine that you're not through on the empty.
I really like this layout, it fits us.
Yeah, with this minus the rotating station. What this layout gives you, besides flexibility, is incredible productivity. We talk about building the stack at night. At night, I can build a stack on this conveyor here, a mixed stack. I can build a mixed stack wherever, here or here for the rover. So now I've got 37, 60, 70, 80 sheets already in position to cut tomorrow. That's going to take you how long? An hour, 2 hours? What's the windstorm doing those that time? It's going to reload the windstorm. I mean, you can skin the cat of how a windstorm works so many ways. And there's not one that's more right than wrong, so long as it's producing. Right? So there's so many ways it can produce for you.
In this one, Jason, is that station inside the wind store a labeling station?
No, it's just
Just a stack.
just a stack. Just a stack.
Could be.
It could be.
Could be.
Could be.
If
That's
you've
why
got
I was
label every part,
was
you put
highlighting.
the label station right there.
Moving forward. So moving forward, when I was in North Carolina with Jim and Randy, Jim challenged me to say, how come you're not proposing, or why don't you, it was more like, why haven't you, proposed a more automated plant? From a high level, a more automated plant versus what we saw at all of your plants, which is a big or small building with machines wherever. So with that said, we came up with a little plan.
What's the name of this one?
It's the same 0_16529.
Only got one of those. So is it
Okay,
the
how
same
about this
drawing
one?
you run before?
North Carolina layout.
North Carolina layout.
Same thing.
Okay, I got the North Carolina layout.
We're gonna have to rotate this one. A much different plant for a much higher volume. And it's a whole plant here.
Sorry.
So
That's a question.
Sure.
Maybe right off the get-go here. Are there any plants that have 2 nested base machines like this does, and with an operator offloading?
Yes.
If you can, he can keep up.
You just want to know when I want to approve it, right, Randy?
it depends on the nesting configuration.
Thanks.
Like I said before, the customer in Minnesota, his rovers are closer than this. So sometimes he does have one guy that unloads both. They're making kitchen cabinets. So like sometimes if they're running pantry ends, 2 foot by 8 foot, and they get 2 per sheet.
Yeah, there's
No way.
No way.
But if they're running a regular nest and they only run 4 by 8 pre-finished plywood. So if they're running wall end panels, they might get 10 or 12 a sheet, and they're doing all the drilling, so it might take 2.5, 3 minutes. One person can come close to managing it. And this customer, because like, not this one, because like I said before, they're producing so much more than they ever thought they could. Sometimes they're willing to sacrifice the efficiency of the machine by letting a nest wait on the outfeed conveyor for the one person to unload. Sometimes they just, one day it's a high production, they put two guys there.
Right, right.
Now, for this one, you've utilized his internal conveyor mechanisms and
No,
you've had.
no.
You've had.
This was a brownfield plant.
This is a ground plan.
I don't know what the space is.
This is grass.
Here, no, brownfield, existing building.
Oh, in his existing building.
In his existing building.
No,
right?
an existing building.
Okay.
Actually, most of our, if our high-speed nested-based programs are probably gonna be 4 minutes at least.
I would say.
At least, maybe 5, so we could run, you know,
Yeah.
2 to 1 operator.
It'd be very close, really.
But listen,
3 minutes for a operator to offload the nested.
Not so many,
no,
Which is
not in what I
around
looked
2-3
at.
minutes for an operator to
right? So,
offload the nested cell. So if you have a cycle that is around 5 minutes, definitely the guy can attend to machines. Possibly do it. Yes. To
I
sweat.
have some that are longer.
yeah, I mean, most of this stuff wasn't real long. Anyway, let's go back to the layout.
I
So,
was looking at what I viewed and some of the other things.
yeah, that's what I'm saying, it's stuff that I don't know that you produce.
I'm not getting, that many sheets off an hour.
Your nested machine.
Yeah, but I'm having to hand load.
Yeah,
Exactly.
offload, yeah.
That's the biggest part of it, I'd say,
It
it's around
is.
65%. The machine is cutting in the wood 30%.
Exactly.
so you're getting 45 sheets a day.
And now imagine taking that
That's normal.
40%
That's-
to 80%.
45.
There are other guys, 45 sheets a day, 50 sheets a day, 60 sheets a day. Standalone nesting machine is
Max.
35, 40. That's it.
Without a loader.
Without any, it's not even just a standalone machine. You add some, a sweep arm and maybe you get the 50, sweep arm and offloading, maybe you get 65, 70. Until you automate, that's when you start getting to 80, 85, 90. And like Cesare said, we've got customers with 110, 120 nests in a shed.
Which is just what about.
But-
So-
Plus is pushing it, it's not the operator dictating the pace. In your case, how fast or how slow the operator is moving, that makes a difference. In this case, the material is coming out. If the operator is not fast enough to catch it, then you know you have a problem, you know what I mean? You can
I know,
measure
I'd
it.
rather, it's like the edge bander issue, right? Like, I'd rather have a machine capable of running it, and, my efficiency is related to, the machine level, so to have the guy wait on the machine. You know
With
what
a
I mean?
big difference.
It's
On
like
the bender,
the-
in the bender is extremely challenging, but on the nested base cell fed like that, even with a fast cycle around 2-3 minutes, an operator is not challenged in keeping up with the machine.
Because he's only off.
He's only offloading, that is what he does.
He's not loading.
So I think, but it is important to know, what are you running at from a travel and cutting speed today versus what you're running at? I mean, part of it, you're picking up the travel speed.
I am, yeah, the actual cycle time is so much faster than what we are doing.
What are you
right
running
now.
today?
Well, depending on the machine, like, for example, on my Biesse out here, they're over 30, it's got that single arm, okay? It's capable of running faster, but I can't run it beyond 900 inches per minute because of movement, when it changes direction, okay?
So 900, that was the
900
question.
inches a minute.
So what are you running in today's world?
I got other machines that max out at 600.
I know,
That's my fastest machine, right?
900 is about 25 meters per minute, and that is an average speed, but we run, you can run with the tools that are available today easily at 35, 40, 45 meters per minute. How that is gonna make a big impact in your productivity? Probably not. I mean, isn't that you cut twice as fast and now your cycle is half. It doesn't work like that, but you're gonna get the benefit obviously.
Yeah,
from it
well,
faster.
the biggest benefit is the fact that like I said, I'm only running the machine 30% of the time. Most
Yeah,
of the time.
that is the biggest thing.
That is stop waiting for the operator. Clear the bed, blow it all off,
Ah,
get ready, and then load it on the sheet on, suck it down, and then stand there.
Speaking of which, today, all the blowing, all the dust that is building up and up in the air behind the machine. On a machine like this that is totally automated and you have dust collection while you're cutting, dust collection while you're pushing, dust collection on the belt, the amount of dust that is left over after everything is done is really a small portion of what you're experiencing today.
Yes, I've seen it, I've visited a few plants with it, and they definitely are impressive, the difference is huge.
Technology you're gonna pick up on the just in the nature of the technology and generation of the machine. You'll pick up, but that's not where the benefit is.
Okay.
The machine cycle time is the machine cycle time.
I think you will be able to run around 40 meters per minute on this machine, but
Yes, and that's significantly faster than what I am right now. Look at the Northwood One maximum speed is 600 per minute.
It's about,
So,
it's close to 1,400 inches a minute, 1,500 inches a minute.
so it's running faster. I can get, like right now, mostly running with the two wing cutter, so I could go to 3 wing cutter.
you can get to the 3
Yeah, the combos that are in Baltimore right now run about 1,500.
And you can be able to run 1,400, 1,500.
Yeah, that's
Yeah,
not.
so I have the ability to run that here.
Okay.
Sorry, I didn't want to digress, but I just wanted to
No
make sure.
problem.
So Randy had a question here, says, have them go through the flow process.
I'm pretty sure I will.
What's that big giant thing in the middle? Is that an edge
Yeah.
Yeah,
Yeah, what is that?
it's an edge band. But let's talk about the whole thing first. It's a big layout. Should actually, let's do this. This PDF is not so good.
So whatever you're doing, you're gonna send me, right?
You have the PDF. I don't know if you can open CAD.
Yeah, I had the PDF, but
You want the CAD?
you tell me. Whatever. I just want to make sure I'm matching whatever
Yeah,
you're
same
doing.
layout. I just need something I can zoom in better.
Yeah, he's got CAD. Okay.
Yeah, it's the same layout. Just zoom it out.
Okay, so rotate the same way, so you're not confusing me
Which way you want, right to left?
clockwise.
Let's go back to PDF.
Undo.
We're so wrong.
Yeah, exactly.
Undo.
Okay, so much easier, right?
Yeah, exactly. Okay,
All right, so maybe I'll try to follow along with you here.
so this follows this. I'll say the whole thing. The concept is the same as the saw I showed for Louisville, where it has one conveyor inside of the wind store, which is this one or this one, and one conveyor outside of the wind store. So the reason for having the two conveyors, or the one conveyor per saw, outside of the wind store is because I don't want to waste movements with the wind store for a whole stack of white. If you need to cut whatever it is, 30, 40, 50, 60 sheets of white, drop it on the conveyor outside from inventory outside, load it to the lift table, and away you go. No problem. But if you need to cut a mixed stack, I want 2 white, 2 black, 2 green, 2 5x9, 2 5x8, a couple 5x12s, some solid surface, whatever. You can load it directly here, one book at a time. You can build a mixed stack on any one of the two conveyors inside. This configuration gives you the most flexibility of any saw we could put in the wind store, because you can load it from 3 different positions. The rovers, as they were in the 2 previous layouts, is just 1 sheet at a time on the in-feed conveyor. It's shown as a lift table. We didn't mention this prior, when we put rovers, nested base routers inside of the wind stores, we replaced the lift table where a normal stack of material would go with a simple phenolic table. Because I don't need a lift table, it's 1 sheet at a time. So drop on the table, we do the alignment, the labeling, if we need to, pull it on the machine. We have 3 in-feed positions, it could be as many as you want. So now coming out of the cutting. So I've got 3 conveyors coming off of each saw, where you're going to take the book off the saw and drop it on the conveyor. It could just as well be a scissor lift here, here, and here, so you have height adjustments, you're not bending down. I would certainly recommend that. For each rover, sorry I'm zooming in and out a lot, but for each rover, it's just 1 conveyor. You're really loading onto it, then pushing it out. All of these conveyors marry up to these 2 shuttles. These shuttles could be manual, they could be automatic, they could be semi-automatic, whatever you want. Not a big buffer here. Really, your buffer is going to be these conveyors, and then the length of these conveyors. Now we have 2 different edge banders here. Jim, you were pretty adamant to me that I want to find a faster way to edge band. Sometimes I run a lot of the same thing. This is a fast way to edge band. So what we have here is a Stream B. So it's the version of the machine larger than the Roxel that you guys currently own here and in Dayton. It has automatic loading with a single position. So you bring a stack in here, the gantry picks it up, drops it, away it goes. Once it goes through the edge bander, this gantry picks it up, rotates it up to 180, so long as lengthwise going back, and then this gantry will pick up and rotate either 90 or nothing if it's done a crosswise or the opposite lengthwise pass.
So where's the operator there?
I don't see him.
So there's no operator.
The only person you need on this cell is a person to make sure you've got glue in the machine and the right tape in here. So it's not an operator as it is a person who watches the machine every now and then. We could certainly add a hopper or a vacuum feed for the glue. So you dump whatever it is, 50, 60, 70 pounds of glue into a hopper, and then vacuum, we automatically vacuum feed it into the pre-melt.
How much?
1.1.
Okay.
It depends on the configuration of the edge bander. It may be less. It depends on the edge bander. With this, you could estimate 12, 15, 16 edges a minute without blinking an eye. Now, if you wanted it to be flexible and still do that same, call it 15 edges a minute, meaning that stack that comes in isn't a homogeneous stack, it's a mixed stack within reason that I can manage with the feeder. One part could be different from the next, same thickness of course, right? But one part could be white 4 sides, one could be white 3 sides with green on the 4th side, some part could be 4 edges, some could be 2 edges, some could be 1 edge. I don't care. Close that back up.
So each part would have to have a label on it.
At that point, yes. Now, if we ran it the way Jim runs it here, where it's at least one label on the top of the stack, which means the whole stack is the same program. At that point, it's still an open loop, but it would be run like it's a closed loop because it's 30 pieces in, 30 pieces out. But I'd run it like an open loop because I have 30 pieces coming in here, but the minute that 30th piece is picked up, this trolley can load the next one. But the loop is still full of parts running around. So I can reintroduce the first piece from the second stack while I'm finishing up the last, 5, 6, 10 pieces of the first stack. That's the open loop management. But that assumes that the second stack is the same program as the first stack. Otherwise, if you want true batch one, every piece different from the next, I need a label on every single part, and I need 2 barcodes on every single part. I need a barcode for the lengthwise pass and a barcode for the crosswise pass. And I read it because we have a barcode scanner right here with 3 scanners, and each scanner overlaps. I can read up to a 10-foot part in length.
How does it handle edge banding like the ends on narrow parts?
You see the small edge bander just above this one?
Right.
Exactly. The limitation isn't so much the edge bander as it is the automation. With this style of automation, we're limited to 150 millimeters. Is the minimum by 250 is
Jason,
small as we can pick.
repeat the question, make sure the guys on the phone heard
The
that.
question was, how do we manage the crosswise edge of a narrow part? End capping, yeah. We do it on the smaller bander on the top because the automation, the feeder and the stacker cannot manage really narrow parts. Our limit for picking up is a 150 millimeter wide part, which is 6 inches. Now certainly, I assume you have some parts that are going to be in that 3 and 4 inch range you need to end cap, which is normal, which will be done on the auxiliary edge bander shown above.
Could it also be done where blanks are cut in large panels, edge banded in sheet form, broken up on the saw, and then it's treated?
Yes.
Just the long edges get banded?
Yes. Then you just have to worry about the management of getting it back. Right? So you got to pick your poison in that case, for sure. So after we have the parts edge banded on either one of these 2 edge banders, or if we don't need edge band at all, it bypasses.
I got a question, sorry.
Yes.
Randy's asking, can you add a molder head to the big bander?
Absolutely. The big bander can have an internal milling unit. It can be a manual milling unit, which is manually tilted between 0 and 90, all the way up to a full CNC unit to where it's CNC in the Z-axis. So I can machine on the bottom, the top, then CNC in the tilting from 0 to 90, so I can machine on the end. and I can have a 5-position tool changer. So yes, we can have that on the inside. We can have an external NC grooving unit as well to groove the part that's outside of the edge bander. And it's NC, so it can go to any position.
So the bottom line is, the parts that work on that edge bander, your productivity is about 3 times what a man could do.
4 times.
At
what he's
least.
done. He's 4 times what he's done time study. He did the time studies at 4.
At 4, right?
But I really,
You're saying 12 or
12 at a minimum.
12?
15 is a good number.
Okay.
And really, I tell you, it depends how smart you can be on the incoming stack. Because the limit is not the edge band. It's the automation. So if you can bring in a 1x2, and I can pick up 2 at a time. Remember, with this edge bander, my dynamic gap is 350 millimeters. Part to part. I don't have the limit like Jim said. I have a 25-meter minute edge bander that I'm running at 18, or I run it at 25 with a really low part count. I mean, can I take that study and run 5 parts, 6 parts? Sure, I can. I don't think you're going to find in your plants that you're averaging 6 parts a minute, 6 edges a minute on your edge banders. I don't believe it. Are you going to get it for some portion of the day? Maybe in the morning. You're going to get it on Monday? Yeah. You're going to get it on Friday? No. Those sorts of things. You're just not going to get that consistent all day, every day, 6, 7 parts a minute. 4, I think, is a very even, good average that you'll achieve throughout the day. Something like this doesn't get drunk on Thursday. It always comes in on Monday. That's the point about automation. Simple automation like this. We can go to complex automation like a robot. A robot requires you to have somebody in the office that knows how to program the robot. So it's a different beast, and it's not required here because here it's the same thing. More or less over and over. You use robots where it's not the same thing. Over and over.
But there is enough automation that you could hook the label to changing a magazine or looking at different cutting with the cutting edge. That automation exists.
That's the edge bander, yes. If every part had the 2 barcodes on it, linear and crosswise, in that label I can manage everything.
Right.
Change the color, corner rounding, no corner rounding, groove, don't groove.
Right.
Which tool do I do the groove or do the milling with?
Yeah,
Do I
simple
tilt,
on
do I
off,
not
right?
tilt?
Yeah.
Beyond simple on and off. And every part can be different from the next.
Okay.
It's really interesting. I mean, even on this machine, it has because this machine wasn't in the price list. In this machine,
Oh, I know.
we can have the ability on the corner rounding to manage multiple radiuses without stopping the machine. So if you're running a part that has 1 millimeter, then behind you have a part that has 3 millimeter, and then one that has 2 millimeter, I can manage that without stopping the machine. The gap gets bigger for me to change the tool, and I'm not changing the tool with the tool changer. I'm changing the tool because the tools are nested inside of each other pneumatically. They move in or move out.
And all the changeovers controlled by the barcoding on the labels.
It's controlled by the label. It's controlled by a database. All the labels going is going into a database and grabbing the recipe.
So the information that's on those labels, that's done at a.
It's a database.
Yeah, you
You're
do
doing engineering on it, and they,
Yeah,
okay.
you're engineering it at the cut bill level.
Yeah, exactly. But it's a database that probably doesn't change so much.
Right.
It's fixed, you just tell it which line to go to. You turn on or off. And yeah. I don't know how many edge banding colors you run.
What do we want?
Take it out to my guy in left field, okay? He has over 1,100 edge banding colors. That's not important. What's important is that inside of his bill of materials, he knows exactly how much edge banding he needs. Exactly. We know how much edge banding is left on the roll, because we know what the roll starts with. He now knows when he starts the job what roll is in the machine, and if he needs another one. More importantly, the guy that, in his case, the guy that runs the rover has enough time that when the rover's running, he walks over to the edge bander, he looks at the list on a computer, what's coming, he grabs the coils out and puts them in the machine. The edge bander never stops. That's the point. The edge bander keeps running, keeps running, keeps running. It's all about managing the information. You have the information, you're just not using it. I guarantee you. You're billing your customer for the edge banding, I'm sure. So you know how much edge banding you're using. And you know which edge banding you're using.
At least don't do anything with it.
Right, so put that information to work for you. And make you more efficient. back to the layer. So either we're edge banding or we're not edge banding, so we have the pass-through lanes all throughout. And then we have the drilling. Now, we have 4 point-to-points that are sitting back to back. So 2 there and 2 here. It's in and then it's out. And then at the bottom of the 2C at each pair, there's a horizontal going down the machine. This is for your flexible drilling. For your fast drilling and light routing, we have a through-feed machine. So it's through-feed routing and drilling on top, bottom, and all 4 edges in one pass. All 4 edges, top and bottom, on one machine. That's not what you're doing on the point-to-points. So it's a very interesting machine for concept. The machine may or may not be the right machine, but this concept is a very interesting concept.
Is that a gang drill?
No, this is flexible. You have 2
Sounds like a
edges.
long cycle time to make.
For the horizontal, it's 1 at a time, or 2 at a time. But for the vertical, on the top and the bottom, you have 44 drill bits on the top and 44 on the bottom. Sorry, 22 on the bottom. You can have 2 electro spindles on top and 1 on the bottom. You can have 1 tool changer on the top, on this particular machine.
All independent, right?
And this is running with a feeder and a stacker, so this feeder and stacker is different than what's on the edge bander, because this machine runs at a different rate. So it makes no sense to overkill the feeder and the stacker. We put a lower performing feeder and stacker here, but still maintain the automatic loading and unloading versus putting 2 people on it. Well, why put 2 people on it if you don't have to put 2 people on it? And this machine, like the vertical machines, when routing, it has to go to dust. I can't let it fall down on top of the drill head, it's below. We are putting pressure down on this machine on top of the part, so the part's going through this way. Rollers on the bottom, idle rollers on the bottom. We have side pressure this way against the chain that runs this way. So the chain is what moves the parts. The pressing this way, which takes out warp, is idle rollers on end. The pressure from above is rollers and a shoe, depending what we're doing and where we're going.
And you're representing this as a balanced line.
I have no idea what you're running on this line. Is it balanced?
No, I mean,
It looks like we got extra stuff.
well, I think
No, but I don't think so, because today in North Carolina, how many point-to-points do you have? 6?
I think there's 9 actually.
9. I show 4.
Okay.
I thought I said.
Hey,
We're all wrong.
But I think the key, and that's the thing I think we need to, you kind of showed us good, better, and best. I
Exactly.
mean, Seattle could be the same solution you use at Dayton or Dallas or anywhere else.
Scale this way.
Scaled this way.
Yeah.
Louisville, is a design that could work different. This one, I mean, this is the ultimate, that we'd love to do if you had all the money in the world and we let Randy use all the capital.
But something like this doesn't have to be done all at day one.
Right. There's a plan
I
around
mean,
it.
I don't know what makes the most sense.
Right.
Certainly something you hit me on with was the
Yeah.
edge bander.
Right.
More than anything was the edge bander. So if
Well,
you-
we have 4 edge banders in North Carolina, don't you, Randy? Not
Yeah.
counting the mothball ones that you guys laying in the corner.
Yeah, exactly. One junker. This machine here would probably replace
All 4.
at least 3.
At least.
At least 3, if not all 4. But it
Yeah,
depends.
this cell would replace all his advantage.
It depends on the mix, what he's edge banding. You have that crazy metric. At least. 20,000 feet a day, I would say at least. It's a different metric. It's not what I normally go with. I mean, 20,000 feet,
You can,
Yeah.
of an average,
63,000 meters.
what?
Oh.
For feet,
shift and a quarter, assuming an average part size of length of 30 inches.
Now, just as a reality check, and I'm not gonna, obviously there's a lot that you've quoted us for and everything else, but as a reality check, a cell of this nature, what are you talking about in rough dollars?
Rough dollars,
in your thing.
I got it. So let's just say 450 600,000 for the saw, 600,000 for this, or 1.6 for this.
Right.
We are, call it 1 for the edge band.
2.6.
2.6, 2.8, and a 3.4. You have point-to-points.
Yeah. But you got easily 3 million plus
Yes.
in this line.
Yes.
So, I mean, again, I think this is the, you don't have to do it all in day one is the key.
Exactly.
And where you evolve to is the key. And I think this again gets you to the thinking process.
And this was the thinking. It was the challenge.
Absolutely.
Yes, we can do it.
But Randy, we're not doing this in your shop tomorrow. I just want to make sure that's clear.
We can take it further than this too. Oh, for sure.
And you're still not gonna get it tomorrow.
I don't go home yet. It's all part of an evolution.
It's all scalable. It's all scalable. Back to the Seattle layout, we showed a saw and a CNC.
Well, and for IDX,
Pull a saw, and keep that space for the CNC.
and
Exactly. You can start this wind store with 1 saw, 2 saws, 1 rover, 1 saw.
for IDX, it's an evolution. It really is. I mean, I don't say that lightly. And it may be taking some of the equipment we have, along with a wind store or other things, and add to, but you gotta start somewhere.
I agree. Something like this, you're not ready for.
We're not ready.
Information wise, right?
That's not, you're not
We're
ready.
not-
Just
You
like
can't manage, you can't manage the data needed to run that system.
Right, but
Yeah.
But you start somewhere.
something like this, yes,
Right.
completely different.
Correct.
So how difficult is it to scale a wind store? So say you start with this, 18 months later, 2 years later, you're ready to double the size, have a
Okay.
single wind store with
If you want to
2
make this
saws.
larger, the one that I'm looking at for here in North Carolina, the one for Seattle's a little different. So the ones the bigger ones, the faster ones, work with lasers. So I have a reflector here, a reflector here. And then on each side of the gantry, I have a laser. Move it as far away as you want.
So same controller.
Same control.
The one we looked at,
Take
in
it
Italy, what was the
down.
size of it? That huge one you had in Italy, it was in your shop. You showed them? Yes. That's the widest one in the world. Right, I was gonna say, that was the biggest one you had done.
We can't ship 16 meters across the ocean.
The limiting factor, right, the limiting, there's no limit to the size of this, with one exception. The top to bottom, that moving gantry, we can't ship anything bigger than 12 meters.
And this is 12 meters by,
In length.
48.
In length, theoretically, you go as large as you want. If you get too big, you'll never get the strokes that you need out to fill a machine. Sure.
Right, the guy in Wisconsin, he has a 12 by 48. He's got
8 meters.
5,500 sheets inside, staggering. This crazy customer 2 weeks ago bought a 12 by 62. And he's gonna make his stacks 8 feet tall. 2.5 meters. The standard stack height is 2 meters. The guy in Wisconsin found, remember he's out in left field. He went up to 6,200 sheets. At that point, he found that the stratification of the material inside of the wind store got slower. He brought it back down to 5,500, and that's where he finds is the best place for speed and flexibility. And he always runs 150 meters a minute regardless.
But the short answer to Isaac's question
We
is,
can extend
you
it.
can extend it as far as you want.
It would not take a significant reinvestment to.
Right.
Your investment in a wind store is the gantry and the software. It's steel, in a vacuum pump.
But how many pieces of equipment can be serviced by one wind store
Okay.
efficiently?
Right now, we
4 or
have,
5 or 3 or?
it depends how the machines are connected, okay? We have a wind store in Seattle that's feeding 5 rovers and 3 saws. Not one of them is connected to the wind store. We have, of course I
I
can.
know the guys on the phone can't see it, but.
We have, we'll pull it up. They're a kitchen cabinet manufacturer, so it's, and they're not far from your guys.
So the answer to the question is there's only one answer, because these aren't directly connected to the wind store. They're not fed directly by the wind store.
So it's nothing you sent me, right?
Store
I
actually
didn't, let me send it to you.
Yeah, there's still some people online.
Who was
Belmont Cabinets. They're in Auburn, Auburn, North Carolina.
Auburn, Washington.
Auburn, Washington, which is about 25 minutes south of Cincinnati.
Yeah, you know where it's
That's where I used to live.
In Auburn?
Live in Bonnie Lake.
Okay. Where are you? So this customer while we're waiting to send it, they already had all of these CNCs, all of the saws on the right-hand side. And they used, forget for a moment that the wind store is here. They built already this conveyor here, and they put roller conveyors on top of the scissor lift. So in the past, they had these machines further apart. And they would have a forklift that would turn into load these 4 conveyors. And then the operator would just walk around and push it onto the scissor lift when it was empty. So now the weight begins to carry. Still on the outbox. It's amazing. We feed these 3 saws and these 5 routers. And we manage remnants inside of the wind store.
all you're doing is doing output, shooting pallets.
We're building mixed stacks.
Mixed stack.
So we have these 3 conveyors plus this conveyor. This conveyor is only for this machine because the trolley's only 8 feet. They have one machine that's a 5x12. These 4 are 4x8. So when we're loading 12-foot or 9, no, only 12 foot to this machine, the shuttle comes over here and just sits here and acts as a pass-through.
Shuttle's automated.
Completely automated.
Everything's automated up until you get to the machine conveyor.
There are no people in that window. Not a single one.
How do the jobs look like? I mean, they're just like.
They run
like
kitchen by
the
kitchen.
works where you're lining up on a work sheet. Is that the way that works, or how does that work? We had a bar stand that holds the saw, and workstation, word list. Is it just like that for the bar to program that?
Yes.
In simplest form. I tell you something.
I'm sorry, can you go back and go, I just not finally got the drawing up, so could you go over again what you're pointing out and everything, so I can kind of follow along here and show these guys?
Sure. And we'll come back to your
Sorry.
question, because it's a very interesting point that I will make a very interesting comment that I don't think we've thought of. Or way to produce, excuse me. So this customer had, years ago, they had these 4x8 nested base routers, and they put this in-feed conveyor at the front. So they'd have a forklift that would come in and drop the stack on the in-feed conveyor, and they would manually push it on the machine. So they used to have these machines further apart. When they bought the Windstor, they pushed them as close together as they could physically do it because of limitations with posts and what have you. So now what we're doing is the Windstor is delivering material onto this shuttle. The shuttle is completely automated on this track and delivers material to these 4x8, and to this 5x12 router. In this window, there are no people.
Window, come on, window. All right, you guys see that's what I'm circling. There we go.
Yeah, so from all the way to the outfeed of the rovers to the front of the Windstor, there's not a single person. The way it works, since this is a manual gravity conveyor, at each conveyor, we have a light stack. So back here, the operator has a signal, so he knows when the lift table is empty. Then he knows he has to walk up here and push the stack on, because it's not automated.
And then once the stack's pushed on, then it's not a load.
Then it's empty.
Right.
When any one of these conveyors are empty, this goes to sort of answer your question. The next available rover gets the next stack. We're not writing programs for each rover, because those 4 rovers are identical. We're writing a program for a machine. Who cares? Because they push the programs once the stack is delivered.
So all the tool configurations are exactly the same.
Same. If we're building a stack for the saws, there's one else. The 3 saws are over here. They build a stack into one of these 7 in-feed positions, and the forklift comes over, takes it out to the in-feed, or to the lift table.
I would like to make a comment regarding your, the tooling configuration. On our
Even
machines,
if it's not the same.
because we don't work with, we could work with ISO code, with G code, but in the reality, the majority we're working with the CIX, CIT5s. Those are higher level programs that can be run on the machine, even if the tool configuration is different, as long as the tool names are in there. You know what I mean?
Proper.
So
they
if
can
I
be in
call it,
different positions.
yeah, if I call for a tool, I don't care if on this machine is on tool changer number 1, in the fork number 1, and that one is on fork number 6. It's gonna pick up the tool regardless with the same program. I don't need a dedicated program for that specific rover or any other one of machines.
It's really interesting, all their panel saws are front load.
Yeah, all of them, even, except this one over here. Actually, this one's front load too.
They're all.
I think this one over here is only cutting backs.
Now, just out of interest, on all these machines that you're feeding with the Windsor, how many of them are Biesse machines?
All of them.
Well, number one, it doesn't matter, because it's not directly connected.
That was the question I was.
But all.
They all happen to be, they don't have to be.
Except for the sauce.
Except for some.
Yeah, they all are.
So
That's on the right.
Jim asked a question about the programming and the work list. So with this customer I mentioned just already, they program by 4x8 router, and then the first available machine gets a stack of material, and the program follows the stack. I'm going to go out on a limb and say every one of your locations that has a saw or a nesting machine programs by job, and you have no idea or very little idea how long that job takes. If you have multiple nesting machines, this one might finish after 1 hour, 2 hours, this one after 3 hours, whatever. Then you do your best to keep that machine busy during the day. Fair statement?
I would say.
Fair.
Fair. Now, let's just say you have,
Okay, which one are you going to?
back to this one, but I'm going to do it in CAD. So let's just say you have
Doesn't make it too easy.
Make sure
2
I'm-
nesting machines inside of a windstorm. Instead of having a single work list per machine and not knowing the time to complete that work list and hoping you can get the next one behind it, you don't waste time. Imagine having 2 NVCs, nested base routers, running off of a single work list. And now the first available machine gets the next sheet. How does that? It's pure magic. Because in this case, it's a system. We have feedback, and this is when you have an MES and what I was talking about before, feed process, it's about communication going both ways. So I have feedback from the rover that says the in-feed table's empty. I need the next one. And then when the next one's down, we deliver the program. The machine is purely a slave. And that's the most important part, is that machines connected to the WinStore are slaves to the WinStore. And we're pushing the program with
So it's
the
really
machine.
not importing the actual work list into the machine until it actually chooses
The machine.
the machine.
Remember, you can feed one program at a time.
So if you had 2 machines that weren't identical, but
Very
they could
hard.
run identical parts.
But we're not gonna have a competitor's machine inside of the WinStore.
I understand.
Okay?
But if you had 2 machines that could run,
Could run.
then you could feed it that way. You could decide which one it run and it would decide the program. But you're not gonna put a competitor's machine inside of the Windsor ever.
I won't say ever. We have a wiki inside of a Biesse in Germany, but it was a new machine. And this is the point, it's very, very difficult with older machines, especially when you get into old controllers.
But the new Biesse that we have in LA, you certainly could put within the Windsor.
Cesare, why don't you answer that one?
Cheddar. No.
No.
Here's what you can do.
Not new enough?
Here's what you can
No,
do.
there are lots of things.
The short answer is no. The long answer is,
Yes.
instead of having the rover here, imagine it's, give me just a second.
It's the other layout.
Oh, now he's gonna change the layout on your graph.
Yeah.
There's no way I can keep up with this.
You can't keep up with this question.
Okay, it's more or less here. It's just outside, and I have a chain conveyor inside the wind store, and I build a stack, and I deliver the stack out, or a sheet.
Okay.
Now you need to modify the lift table to accept the sheet. It's the communication. We would be happy to give you a fabulous trade-in value on that rover for a new one to put inside.
Yeah,
That would fit.
And then we can absolutely guarantee the work.
But it's all about communication between the store and the machine.
How about our new, edge banders? Could they go inside of a wind store?
No.
I'd be happy to put your engine better inside of the wind store. I don't know what we're gonna do with it.
I'm really trying to see technology-wise. where-
What I can do,
Could you take one of the newer Biesse edge banders and put it inside that automation loop that you created?
no. But what I could do, because the stream A is not a stream B. And what I mean by that is a stream A is meant to be a machine that sits in the middle of the floor, standalone. So the in-feed and the out-feed portion of those machines
Stream B is your integrated machine.
are not meant to have all fully automated solutions. What we can put on that machine, did I not have an option for it? Excuse me, is the W4, which is,
Okay, whatever you're looking to, you didn't send me, right?
now this is the,
Yeah, this is the one that's.
the document that has all the information in it, the quote package, RFP package, whatever you want to call it.
Okay, so that's, you sent, yeah, we got that box. I gotta go find it.
Now, you had this open before, I emailed it to you.
You did?
Yes.
Oh, I'll just leave the name up there. What's the name of it? BSC Core Equipment Offer? It's an
Okay.
Excel spreadsheet. Hold on, man, I'm still trying to find it. There it is. Okay, sorry.
I've already put past you.
What page are you on?
Yeah, now he's not even using it.
What?
Because what I'm looking for is not there, so go to your browser. This is what I can put on your existing machine.
This is.
So there's automation.
Going to YouTube?
You type in Biesse, RBO, W4.
Hold on, I'm not there yet.
Oh,
Holy crap, why is it so freaking slow?
And don't download it while you're there.
Okay, what am I searching for?
Yes, it is.
the title right there, delete the screen.
Yes, it's 3
You can just type in Biesse, RBO, letters RBO, and then the letter W and the number 4.
W number 4.
Yep. And this video should pop up. Or you can just type that.
He's looking at it.
BSC Stream A. Winner W4 automatic edge banding cell.
Perfect.
All right, now we're cooking with gas.
Later.
You're just a little bit ahead of me. That's okay.
That's okay. So what this is a
Did have a 2D one.
return conveyor. Let's make it full screen. Return conveyor with a gantry in the back that picks up, rotates, and returns or picks up and stacks the part. This I can absolutely add to your existing, or even existing competitive machines.
It is not like it.
What's nice is at the, you don't have it yet?
No, it's just going real slow. Okay.
Okay. What's nice is this section here. We'll wait till the part comes back and you see what happens. But it's what I said very, very early in the conversation. The operator does not have to move far at all to bring the parts back to reintroduce into the edge bank.
This is what you have to show.
We had this in Atlanta and we had this in Ligma, or Milan.
Well, yeah, they're both, but I.
Yep. Now imagine I replace, hold on. Back to this. I have an option, come on. I have an option to replace this lift table here. This is a up and down lift table, higher table, excuse me. I can replace that with a roller and belt, which means as a roller, the part's going to come down, it's going to come onto that conveyor. Then the belts pop up and it transports the part to the operator. So he's really not moving. It makes it a much, that's what I was trying to do before with my phone. Thank you. So replace this with a roller and belt, so it automatically brings the parts back to him. So instead of
He's not reaching at all.
exactly. So here we have an L-shaped air table, really short one here. And then we have, there's an there it is, a nice air table in front of the machine. Makes it much easier to load parts into the machine. I could offer the air table to put in front of your machines now as well. But by putting the roller and belt here, we get rid of this short air table, the U shape, and make it just an L shape. This machine is capable of going 10 cycles, up to 10 cycles a minute. So it means you could
So it
feed
doubles your output.
at least.
More rack day.
At least. And the investment is much less than buying a fully automated line.
And what's the
The investment for this, as it's drawn with the lifting table, is 110. If I get rid of the lifting table and put the roller and belts, it's about 125. Now, so versus $600,000 for the automation on the Stream B, which gives you 15 edges a minute, this can give you up to 10 edges a minute. I'd rather buy 5 at 125 versus 1 at 600.
Right. Yeah, especially in our situation.
Exactly. Now, what I think is interesting, could be interesting about this, with the stacking, the stack height is limited to 800 millimeters off the floor. Let's say you don't build a stack, and you put a conveyor there, and I drop it on the conveyor and it goes out to whatever's next. While we're here, we don't need to look at that. Let's look at this one here. You see this one? No, not the
This one.
EMA.
Which one are you? Yeah, I'm not following this at all. Okay.
Yeah, but you don't want to show the EMA right now.
This one, Rover AC.
Over asynchro.
So this machine is a way to eliminate the person on your point-to-point. So it automatically load parts onto the point-to-point.
Can you set this up to run on our Jet 130?
Wouldn't that be the most efficient way to do it?
Here the loader is actually a single controller with the machine itself, so we cannot do it on a
Chancellor loves to say no.
Hey,
I just wanted to.
Sometimes he says maybe.
The LA gas dropped off, so I can make an LA joke.
Well, the machine died months ago.
Is that even still running? No.
So here it's running doors. So on the left, you see we're breaking the vacuum between parts, which is very important.
Right.
Otherwise, we don't want to pick up 2 or 3. So it doesn't look fast, but it's fast enough to keep up with the machine.
Internal cycle.
And it can work in pendulum because it runs behind the gantry. Isn't that right?
this one cannot.
This one doesn't, but we have ones that can run behind the gantry to run in pendulum.
The K2.
Basically.
Yeah, this one is basically a solution for when you know there is the lunch break, you know, and you want to keep running and the operator is not there because you see that since we cannot do on this specific solution here the pendulum because it's one-sided only, basically the loader is waiting on the machine when the machine is running and the machine is waiting on the loader when the loader is loading and offloading. So it's not a true pendulum solution in this case.
But now, use your imagination. Stop it right there.
Where am I?
I've got 154. I want to look at this view.
154?
At 150, 154, the minute mark.
Perfect, right.
I had it, but it went right by. There we go. Okay.
Okay, so here you have one in-feed system here, and here you have an out-feed stack. Imagine replacing this stupid stack with a powered rollerway that comes in from wherever else. And then have your stack as a powered rollerway going out to wherever else. Now, of course, I need to have the list of the programs. This goes back to the data. Whether it's a mixed stack or it's a homogeneous stack. We could scan a barcode. We don't have to scan a barcode. It's up to you. This is where an operator may or may not be required in terms of passing the information to the program. The customer we worked on, he runs the same thing over and over and over and over. So for him, he just starts the program and goes whatever 500 bases, and away he goes.
Can they serve 2 rovers with the same naming system?
I would love this factory to say yes, but right now they're saying no. I don't think it's going to be long before they say yes. And really, for them to say yes, it comes from the demand.
But what we have done is with the robot loading on the tracks, and so we can load the multiple point to point with the robot loading.
Yeah.
From the back. And working from the back allows you also to keep the option eventually to load any of them from the front. So back to back and side to side with the, we have done that.
I have a question with these integrated systems where you have automatic loaders and you've got point to points, or you've got an automatic, an edge banner that's being automatically loaded. What is the life cycle of the whole system? Because
Oh
if
my
one piece starts to break down, then the other piece is no longer worthwhile.
We have
Are
an
they
edge banner.
7 years or?
Oh, no. Higher. It's
Well-
every bit as long, if not longer, than the edge banner.
Well, generally edge banders, they're good for about 6, 7 years, and then
Exactly.
they start crapping out.
That's
and,
right.
And they become,
Slower and
antiquated or, and all the parts need to be replaced. So
We have
generally-
automation over 15 years old. I've got automation in Delaware that's, I think, 16 or 17.
Somebody's
So
talking
what-
about your system.
But can you, once that edge bander starts becoming problematic, can you plug in another edge bander?
Absolutely.
Is the automated system, does that have a longer life cycle than the edge bander
Yes,
itself?
absolutely.
Because it's technically simpler.
It's technically simpler.
And in reality, can you really do that? Is it?
Replace the
do
edge
people-
bander?
Yeah, do people actually do that? Is that common?
Ah.
Or, like right now, I'm seeing you guys saying, well, we've got this edge bander, can't we hook that up to automation? You're like, no, can't do that.
Backwards compatibility is tough.
So,
No, it wasn't the backwards compatibility, it was the infeed of the edge bander. Your home eggs in North Carolina, I could put that on.
okay,
A home egg, not a brand,
sure,
because there's a different infeed, different outfeed.
okay.
The W4.
Or the W1, the big bad boy system I showed in the North Carolina layout.
So we should expect the life cycle of these items, to be what we already know. What we can get out of a point to point now, or what we can get out of a.
Sure, you nailed it, an edge bander is typical 7 years, a saw 10, 12, a CNC 10. Once you get up into the 8, 9, 10, the problem is not the machine, it's the control. Everything's gets slower. We're to the point now where I don't know how much faster it's gonna get, because now we're at the mercy of the tool.
Right.
Now it's about
you capped out
automating the
technology.
process.
You capped out technology, now it's human's gonna take any advance.
Right, so we have to get rid of the
Credit
person.
speeds and everything,
Right?
that's right.
We get rid of the person, then we just add more machines with more automation to keep up with the productivity volume. Let's go, since we've talked about it so much, let's go to this one here.
I gotta find that one. That was not in my thing on the side.
We'll just do this. Go to the search.
Do you have automation to feed our?
We go WinStore.
Excuse me?
Do you have automation that will feed our existing edge banders?
I don't. Because there's no way to pull apart into your edge band. That's the
I
point.
mean, you've got Cartec shuttler.
I don't do set does.
Yeah, but they're out
But it has to be a homogeneous stack.
there. Exactly. You can't do a mixed stack. If you see
Got
Cartec,
it?
Yeah, I see.
Where'd you hit search?
Which one are we looking for now? Yeah, I did, but
In the Biesse group.
It's not this one. What?
you said, I think that's good. I think that's good.
Okay.
that
I'm
one.
looking for German. What one I had before? No, this is the one in Oklahoma City. Let's look at this one.
Biesse lines, RBO.
This shows you a whole bunch of stuff. Oh, actually, look at this one. Sorry. Look at the IDF.
Biesse, WinStore, AWF. Okay.
Since we talked about it, let's see. So this was last year, I think. So well, 2 years ago. So this machine, even though it's capable of running 150 meters a minute, given the short size of the windstorm, doesn't make sense. Where it's not that fast, but it showed. So it's running at 105 meters a minute. This machine was feeding one nested base router and one beam cell, just like we drew for Seattle and just smaller than what we drew for other people. This WinStore is now installed at the customer in Tucson, Phoenix, Tucson. Doesn't show much there, does it? I'll blame it. Given the cycle of the rover, 3-4 minutes, I can load 6, 7, 8 sheets back into the WinStore while the rover's got it. I can move sheets around, I can dig down into a stack to get the next sheet, do all kinds of stuff.
Prioritizes the tasks to be done.
That's right. The WinStore has,
Well, obviously, we have to tell it what tasks are to be done, right?
you have to tell at a macro level what tasks need to be done. The WinStore has three functions to perform: production, reloading, production, reloading, reorganizing. Get it right. So reorganizing the material inside of the WinStore.
Because it learns from your patterns.
You're right. It's always going to do production first. Load the next machine that's available. Load the saw, load the rover. Build the stack to go out, whatever it is. Number two, it's going to restore itself. So if you have material inside the in-feed area, it will load it into the WinStore. If you tell it it's there, it'll load it in. If it's not going production. The next thing it'll do is reorganize.
Okay, so once the material's in there, it kind of knows what's going on.
It knows
What about
exactly.
introducing new material to the WinStore? Where's that? Where does it come from? You know, coming off of the cold press that is, or the melamine press, whatever, in this situation here, we have, entries where a forklift driver will drop a pump. Okay, so, who's telling that operator, okay, now the next thing we want to load, or the computer wants to load is this.
Okay.
How does that input get in there?
The regular answer, if you're picking up, you have a stack of stuff you buy from somewhere else. 3/4, 4x8 wide. Pick it up, you put it in here.
Yeah.
You get off the forklift, you go to this little, it's a 10-inch touch screen. You have to enter what it is.
Okay.
So you have a drop down for all the different SKUs you have available. You find the one that is that 3/4 inch 4x8 wide, click it, you select it, enter the quantity, top board or bottom board, yes or no, go. Or add pack is what it says. Add pack. Now, if you have something coming out of the laminator, which might be a mixed stack, I need to know the configuration of the stack. We have already developed a software module to add to the WinStore. The guy out in left field who has his laminator 2 fields away from where the WinStore is, where we're generating a label on top of the stack that comes out of the laminator. And it knows the entire configuration of the stack. When we come over to the WinStore, 5 minutes away on the forklift, he scans the label, add pack, and he's done. On top of that, this is something you just did. I only learned this recently. Whenever you add a new material, you have to generate all the information. You need to add the material name, the type, all this stuff we need. Eurostock, the company we mentioned before, wrote an application for him that comes out of his Insight. Insight is his MES 2020 software. If it sees a new material in Insight, it automatically generates the information for the material code and all the other information that Insight needs. He's no longer generating new material codes manually. It's done automatically. That's very interesting. I don't know how long it takes, 2, 3, 4, 5 minutes. Whatever it is, it's time it takes to generate a new material type that you can put in the WinStore. It's still a 4x8, but the color's different. Let's say you have white on the top and black on the bottom. It's why you have black on the top and white on the bottom. It's a different type of material. So it's a different code.
All right. The question to you guys is, have we hit all of the high points that Biesse wanted to go through in the presentation at this point?
I'd say yes, if you have any questions.
Well, I think we may have some questions, but I want to, just because I know you've got some guys that may have to drop off or whatever.
Sure.
Basically, you get the, whether you look at it as the upside you guys get to go first, but, you know, in kind of 5 minutes or less, tell the group why choose Biesse. And I know that's an open-ended question, but I really want, you to kind of put your final pitch in, because as the group gets towards the end of the week, we've got to make the determination and decision, which direction we're going to go. And that decision needs to be made by the end of this week. So I want to make sure you guys get all of your opportunity, pitched to this group. So.
Sure. We
You're
answer.
on.
What's that?
We answer.
We both answer. I think superior technology on the individual components, superior flexibility. Is superior flexibility in, we're not trying to jam one
That's the
solution,
vision.
we're not trying to jam one solution down your throat, we're talking about what's possible, we're trying to partner up. We have our opinion on what works because we've seen it. I think we can prove out our technology by taking it to 25 different places in the United States, all over Europe, to see this technology is not magic, it exists. We're not going to dictate the software, which I think is a big one. Work with just about anybody out there, and have worked with just about anybody out there. Our commitment to the service and support, which have now been put in place to do the right thing.
Yes.
Well, I want to add on to what he said. We're not proposing complex solutions in terms of machinery. We're proposing standard machines, and we're not proposing lightweight machines at the same time. We're not trying to penny pinch by saying, okay, go with this nested-based machine because it's cheap. We're proposing the most robust nested-based machine we offer because it's what you need.
We did that across the board on all the machines that we brought in. We just bring in or show you pricing on anything to impress you with the price. Not one. The Rover B is the biggest, fattest, most expensive. The 7 Series is the top of the line on the saws. The Stream, as you know, is the top of the line on the Vanderbilt. We didn't come in just to try and impress you with a nice package price, because to be honest, we don't know what the package is. I'm not worried about that until we get to the package.
And what you'll find from us that Randy was dancing around, if you will, is we're not offering fluff. I didn't come in with a pretty PowerPoint presentation. It's not me, it's not really Biesse. In the end, it's down to the facts. This is what you asked for, this is what we can deliver, and this is what we can do to get above what you asked for.
Well, and you certainly, we're trying to, I guess, turn over a new leaf from a perspective of equipment, but IDX is never going to buy new equipment every 2 to 3 years. So we need to buy robust equipment that's going to last us that 5 to 7 years. And, we again are going to do a better job in the future. I firmly believe in replacing more timely. But we have people out there that we know, are looking for us to say, okay, put us a machine in here that's a good, robust machine. If we go out there and put the cheapest because it's the best price, that's not going to get us anywhere.
I would like to add that these are all proven solutions that we have already delivered. The machinery that we are proposing are machines that have been on the market for several years. There are many out there, and they're all proven, and there is really nothing new other than something that is going to be tailored to your needs.
Like standard, that's the point. So standard from a support is what you want. You don't want pie in the sky. I mean, even this is not pie in the sky stuff. This is simple cookie cutter stuff for us.
But don't think that we haven't kept up with the technology, because all the controllers, PC-based controllers are all made that Windows 7 jump, so we're already there. The drive technology, servo drive technology, such was on magnetic strip. And not because magnetic strip is a better solution, but because it gives better feedback, and we can adjust for tolerance. We can actually adjust the drive with magnetic strip. So all of these machines, 7 Series has been around for 4 years, the Stream's been around for
8, 9 years.
8, 9 years. The Rover Series has been around for 35, the B's been
There
around.
was evolution in this year that is important.
It's a double-edged sword when you say we're providing proven technology. Does that mean it's old, not innovative? No. All of these models have been innovated, and the controllers are up to speed, and all the electronics, the drive packages and the software are all kept up to speed. It's just the biggest, in each one of the lines, it's the biggest one.
I would say past that, I'd like to think that we've offered innovative solutions, and you didn't ask me to us, me, us to come in and show a solution for Seattle that has automation.
Right.
It's an interesting idea. I mean,
But exactly, we
I used to work with people that his concept was, I want to impress people when they walk into my plant. Whether I make anything or not, doesn't matter.
That's not our game.
I want to impress them when they walk in the door.
Right. Yeah.
So here you have the opportunity in Seattle to say, look at what we have, and produce.
And produce. That's the key.
And produce. I'm giving, at IWF, or AWFS, there's a bunch of presentations being given about Industry 4.0. And to my surprise, we went in and we said, look, this is a fancy term. It means a lot of stuff to a lot of different people. But in the end, what's practical? So we're giving up. That's what I said today. Our whole presentation is going to be about how to use data and get the most out of your data. Because without the data, it's useless. And that's something we haven't tried to sugarcoat. Nor gloss over, whatever you want to call it. And if you want to grow to these levels like this, you have to have the data. And I truly believe some of our competitors won't talk about that stuff. They just assume you know. And then when it comes to the back end, I'm sorry. That's a scary thing. I've seen it. We've seen it happen. Imagine doing something like this and not having the data in order, and we say thank you, goodbye, and you turn the key on it.
Yeah, I mean, to your point, we're not ready for something quite that complex.
Even a windstorm, even just a windstorm, if you're not ready, it's awful. If you expect it to do what we said, the data that we need to run a windstorm is not different. I'm not going to say we hold your hand, but we more or less hold your hand. From the time you sign your till it's delivered till we walk away. And we might be a pain in your ass with the data that we need before the machine gets here to make sure that when the machine gets here, it runs like we said it would.
Well, we have to be committed to do what's necessary.
Exactly, that's the point. So even if you're not, we make sure we get the data.
You know, I have a question. We have quite a bit of material that's prone to scratching. On your nested-based routers, are those are rubberized in-feed and out-feed rollers or belts? Is that how you feed in and out of your?
Well, the belts, there is rubber on the belts, obviously. We need to look at the material because there is an action of pushing, especially on the CNC, on the flat table. When the moment I come down and push, there is the potential for scratching if the material is very delicate, because at the end, what you have left on the bottom is the fine dust.
Right.
And when the fine dust gets into those grooves on the MDF, the potential is there.
Right.
But at least having.
But the in-feed and out-feed are belt driven.
Absolutely, yes.
On both sides.
No, the in-feed is not belt driven.
Yeah,
The
yeah,
in-feed
yes.
is not. So the in-feed is driven by a
If you buy
rod,
a regular machine, not integrated to the windstorm, you have a stack of material. So you have your vacuum head that comes in, and 4 vacuum heads that pick up this edge and then drags.
Oh, I got you.
If it's a windstorm, we drop it on the table, we drag it in
over.
like this, we're dragging it to the phenolic table.
So during the infeed, there is no chance for scratching.
Gotcha.
Eventually, is in the short track before it reaches to the belt. When it gets to the belt, now is carried by the belt, and there is no friction anymore.
But the friction is on the table itself.
Yes.
It's just on the table itself.
Like any other router.
So the better job you do with your dust collection using a different tool maybe, the less chance you're going to have for scratching. To eliminate scratching 100%, it's a windstorm to load and a different windstorm to unload.
Gotcha.
So there's no super.
And there is also different productivity at the point, because the action cannot be simultaneous, has to be done sequentially.
Right. But that is an option that we could.
Absolutely.
That's an
we
object.
have a lot of, you know, any lost time on it, red or something
Typically,
like that going
if you
through,
have
it'll scratch it, you know, slide across there.
on the gloss material, typically it comes also protected. So if you have a film, yeah, then it's no
Unless
issue.
it rolls it up though.
Well, if you buy a cheap seal coat, yeah, that is true, You gotta,
Yeah.
Those seal coats, you're Brian Fritz, anything else you've got? These guys.
I don't think so. Thank you for a great presentation, but no, I think we're good.
You're welcome.
Thank you, Frank.
Thanks to you, thanks to Rob Cox, anything you got?
Say again.
Well, Rob's got a line still open, so I just wanna make sure to see if Rob, any other questions, or if he's on separately.
He ran out of line. I think he walked away a little bit ago.
Okay, thank you.
But just keep that. Oh, thank you.
All right, and I think, pretty much everybody else, I think, has kind of over the last 10 or 15 minutes or so has dropped off, so. Thank you guys very much, appreciate you greatly, and, Brian, we'll go ahead and shut your line down now if you're good.
Thank you.
Can you explain, Lance, can you put the floor plan back on the screen just quickly for reality?
All right. Oh, you're fine.
It's right around the end. Okay, that's it? Ah.
Were you doing a screenshot or something?
Yeah.
Well, you've got access to that in the box.
Yeah, this is all in the box, Brian. Matter of fact, I think I forwarded this one to you. Well, no, that might have been vendor B.
Yeah, it's in the box.
You send my layout to vendor B?
Exactly.
Oh, man.
I have a customer who uses an FTP site, and the FTP site, it says Biesse and SCM. Are you freaking kidding me?
All right, Brian, thank you very much. Talk to you later.
Yeah, I separated all of
I you did for sure.
I have another one that didn't.
So my layouts, my proposals in there is the SCM scores.
Really?
It drives me crazy. So I'll upload it tomorrow, I delete it. I don't let it linger.
So Brian's
All
still.
right. Any other questions, guys? Well, you don't have another question? You can even talk softly right now if you want. You're offline, everybody's good. You're good? Any guys?
Quiet.
You didn't have cover? You gotta remember all of this on 3 days.
Service technicians, geographically located, or how does that work?
Yeah, geographically located, we have.
Relative to our facilities, I guess we should make it more specific.
Located somewhere.
Can we get a map and with
Do we have a
the
map?
plotted?
I don't have a map, I plot it, because we did it from our side.
That would be great.
I mean, we have technicians in Dallas and San Antonio. The one place we don't, I don't think of any, is in Seattle.
No regional Texas.
No, we have
an office with BCIT, British Institute of Technology, across the border. We have an office where we use and schedule technicians out of. I say that, but they never go down.
Yeah,
We don't have any guys based in Seattle. We have guys based in our office in Anaheim. CNC, edge banding, my senior saw guys in San Jose, Northern California.
And then we have our dealer who's in Sacramento, who also has contract technicians that we use all the way up to Seattle.
And do you have a dealer in the Seattle area?
No, not one that's any.
Is that because there's no manufacturing that goes on there?
What?
No manufacturing that goes on there?
Yeah,
anymore?
Bowen's pretty slow.
Indiana, I think you've got a fairly good experience. Our dealer has a couple of good technicians. Rick Ron's got some good technicians. We have technicians that come out of Michigan.
We have also our own guys not too far away.
We got our own guys not too far away. So they're spread out. We can get you a map.
Get some map.
Okay.
Just send some map, that'd be great.
Which is changing the.
Any questions from you guys to us? Anything that, you wanna, as far as the process or how it works?
The process, I think you've been pretty self-explanatory. You've been clear. I mean, you said it just a few moments ago, that you'll make a decision on the vendor by Friday. Okay, so that was the question, you answered the question before we asked it.
That's our game plan.
So then
It's
after
how
that-
we approached the meeting was not to be so specific and come in and say, okay, this is what you have to have. Because we talked about it. Select the vendor, then make sure you select the right vendor for each one of the facilities.
Now, there is an interesting question, and I wanna pose it because, not because you know, Como is one of the presentations. Como is a very large spender of UFTs, and I think we've had that conversation along the way. If at the end of the week there becomes a conversation about partnering Como with one of the other suppliers because Como offers the best solution on nesting, is Biesse willing to work within a scenario that, you know, we look at the integration and we look at WinStore and we look at the edge banners, which we already have a great relationship with, and the Celco saws I think are good. This is something you want to work with.
There's no integration we have to do, because the Como would be outside of the loop.
It would be outside the loop. But as far as integrating, say, you know, we have to work with Eurosoft and figure out what's
Routersim, we've already integrated with Routersim.
Even if he chooses not to use Routersim, you could use BlueCell.
Okay.
Okay, if we have to use Routersim.
We've already done that.
We have
So that's
already.
something that you would come to us and say, no, absolutely not.
Why would you say no? There's no upside saying no.
I just want to make sure. But
Do you have a comment on
Chest raising,
Como?
chest raising.
Besides
Yeah, I'm back in my
the-
entusiasm.
Wait a minute, I'm gonna speak up. You understand.
I do.
It would be crazy for us to close that door, crazy, okay? I understand why Cole's in it, but it would be crazy for us to shut it.
I get it. I mean, and you understand there's always the internal politics
Yep.
and everything else that goes on. And there's no, I will tell you absolutely without any challenges here, UFB has not said you must use Como. There's been none of that. But I do know that as this process works through, the question's going to come in.
For sure. My only comment, as I started to say, forget the machine, is the software. I would not like your money. If you chose Como and you chose to use Routersim, I don't think it's the best decision you could make.
Fair enough. I would expect you to. I mean, you know, we developed a relationship where I know you guys are going to tell me what frankly you believe, and I get that. And I appreciate that. Huh?
You want to be his friend.
I know. But I pose the question because do I know that there is a possibility, whatever slim it is? I do. Sure.
We have done already solutions where with the Winston we were preparing stacks for Comos. You know that happened up in Canada, it happened in Crystal. So we have already done this kind of solution.
You just replaced the Como.
Exactly, but
Como offers no options for point-to-point, they offer no options for vertical. There are flexibility things that you guys have that there's still a capability there in a partnership.
yeah, no, absolutely, and I respect that. On the other hand, we have been replacing those Comos more often than none, and in terms also of material flow, I think we have a better solution.
I think all of the Europeans have a better solution for the nester-based manufacturing itself that Como can offer.
But
Right?
And I'm not disagreeing with that. I think it's, again, I have to put it in play, and I don't want to put it in play at the end of the week, and I don't want to call you guys and say, oh, by the way, we're going to work with.
If Cesare loses all of the flat tables, we're not going to give up on the edge banders or the saws or anything else.
thank you.
That's the point.
Yeah, and I don't want to have that conversation.
This is a kind of
Right
friendship.
here.
You've been open about that all along. I think, in a round way, we've come to the conclusion that that's a possibility.
It's on the table.
Okay, because you've been open about that before, so. I'm
So then to close, it's a fair enough statement to say that we should hear from you either Friday or Monday. Either we're in or we're out, whatever it is.
That's very fair.
Okay.
And I think, you know, it is kind of an interesting one. The only answers are either you're in or you're out, and that's really it. I mean, I don't think it makes sense after going through all of this to string anybody along.
No, I guess all I would ask if it's a no, a few words on why.
Sure.
That's it.
That's fair. That's absolutely fair. I'll give you feedback from the group if that is the answer. I'll give you feedback on if it's yes or if it's a combo with combo. I'll give you feedback either way.
Would you be willing to extend your warranty on your, like rack and pinion systems, on your machines? If they were, you know, we did the PMs like we were supposed to, would you be willing to guarantee or warrant a certain number of hours on that piece of equipment?
Here's what we've done in the
rack
past.
and pinion
Sure.
and your routers themselves?
specific to the rack opinion.
To
I mean,
your guideways, whatever.
The guides.
The guideways.
The guideways that you're running on.
Right.
I'm not sure that's the highest wear on.
It is, it's a high wear, and now, the reason I review IDX, go through the proper PMs and so on and so forth. So, you're kind of like backing up
I'm not backing up.
the quality of your
Not
machine.
backing up quality. We're certainly open to doing things like that. We've done that in the past from the CNCs. We've had people years ago that were actually used an aluminum beam.
Yeah.
We used to have competitors that would just
Mentioned that, they've already done that.
beat that up over the head.
I wasn't really all that excited about the aluminum beam, I was thinking, aluminum, yeah, it's just steel. I was a little nervous about it, they said, if you're worried about that, I guarantee it for 5 years.
Life, he said life.
I mean, that is no movement.
Iron life. Yeah.
Aluminum beam.
Well, Shelby
Today,
Shelly warrants her guide rails for life, so.
My ground guys and the cell booths are for life.
For life, okay.
I've never replaced them, I've been selling for 25 years.
are you processing lots of solid surface?
He's worried about the dust.
Solid
He's worried
surface.
Surface? No, not as a general rule.
Yeah,
I tell you, we subcontract quite a bit of it, but we do produce some in-house.
Well, I mean, today as is with the warranty program we have 4,000 hours, basic 2,000 hours per year. So it's 4,000 hours of use for warranty on the standard warranty. To do something, above and beyond that, I need to understand exactly what you're processing, because obviously if there is something that is abrasive, it has to be taken in consideration. Today on these new machines, we are placing a cover on the guides, which is going to extend the life of the bearings and the guides. But I mean, if you
His question was, are we willing to, and my answer yes. Bottom line. There may be caveats here, caveats there, the answer is yes.
Well, and, there's certainly going to be, as this group, and again, you have the, whatever it is,